All right, I figure enough of the countdown, right? It's like, oh, wait, 1 minute, 2 minutes, 3 minutes. Let's get this thing started. So welcome to this live workshop where we are going to dig into ultrasonic sensors. We already did one where we learned all about how it works, how to connect it. So if you want a little review, the link to that video is posted below. So we are going to move on and control a servo using the ultrasonic sensor and our humble Arduino Uno. So we're gonna have a lot of fun because this ultrasonic sensor is super popular for all kinds of robotics projects. You have your obstacle avoiding robots. I love to use them for props because you can activate all kinds of things like lights, servos, motors, depending on distance, which is very different than how, say, a IR sensor works or a PIR sensor where it just kind of detects the presence. Here, the person has to get within a certain distance, and you can activate different things depending on the distance. But before we continue, I got to say hi to my peeps because I see the comments cooking, a little stew of comments here. And I decided to do this on a Friday afternoon, give you guys food for thought for the weekend. So of course we have Dave Beck. He's like, first one in there. And he wants me to use the burnt version of our breadboard there. The lighting hides the burn marks really well. It looks pretty pearly white to me, but if you look carefully, yep, I probably pushed some voltage, current, all the good stuff for one of the projects before. But we have James Roberts. We have Coast ERBP saying hi. James Roberts said, I saw that. Mayhaps he is also referring to the burnt breadboard. And we also have Paul Radford, Brett Hilton. So I'm going to keep an eye on all of your guys' comments. You know the rule. You got questions, concerns, definitely hit me up here and I will try and get to as many of them as possible. So let's get to the wiring and, playing around with a new nifty camera here. Let's see, controlling it with my phone. And let's take a look at this ultrasonic sensor. So this is the ye old trusty HCSR04, and you can see that it has some giant owl looking eyes, and you can see that they're marked. These are transducers. One is marked R and this one is marked T. So this is the transmitting one and this is the receiver. So in essence, what happens, and there he goes. Let me go grab him. This is what happens when it is live. Actually, it's not so much that it happens when it's live. A lot of these components I have to tape down because they don't want to be part of the show because they're like, I'm gonna get burnt. Did you see the burn mark? That's why he went running. So he's sitting right there. I'll be back. I'll be back. Now, if you have watched these streams, you probably have witnessed a ton of components just like flying off. They literally develop wings and they're like, peace out of this project because they know that the more projects they're involved in, the more chances are that they ain't gonna make it out alive. That's the way we roll around here. So Dave is saying, what, new camera toys? Yes. So I'm trying out a new camera, give you guys a couple different views rather than some of the boring ones. And Paul saying no audio yet. Brett is saying no audio. Let me take a look. It looks like all of our audio is working here. Give me a second. Let me check the audio. And if anybody else is having audio issues, let me know. Or if you hear audio, let me know. So we know we can, troubleshoot, whether it's me or you guys. All right, let's take a look at our settings here. All right, looking good. All right, so some people are saying audio is good. People got audio. So we got a couple with no audio. Perhaps it's a computer settings. But I say on to the building. All right, guys. And we have a couple more people joining. That's awesome. And I want to give you guys an even better view here. All right. So I got my trusty breadboard, no burn marks on this one, and I'm going to have my Arduino. I also have a ruler so we can confirm that we're getting the correct measurements. So let's start hooking this guy up. We were talking about the T and the R for the transmitter and the receiver. And so what happens is from the Arduino, we are going to send a 5-volt signal to this trig pin right here, this second one, and it will receive it. And what it does is it causes this transmitting transducer to send out a pulse. And this pulse consists of 8 little bursts, and they go out and then they hit the object and then bounce back to be received by the receiving transducer. And so as soon as this pulse goes out, it's a specific 8 pulse pattern. This receiver here, or the echo pin, I should say more accurately, goes high and it starts to count. All right, when is it coming back? It's gonna bounce, it's counting, it's counting, it's counting. Then once it hits the receiver, the echo pin will go low. So in order to calculate distance, we kind of got everything we know. This goes out at the speed of sound. So we got speed and time. So we know this time back and forth, and then all you have to do is divide the time in half. So that way you get distance to the object and not distance to and back from the object. And we got everything we need then to determine distance. So let's get this little guy wired up, and he's a little awkward, but I'm going to make him stand up like this. So I'm just gonna pop him in here, his little vampire teeth, and crunch him. There we go, he snaps right in, and we can see the orientation of the different pins. And so the first one on the left is VCC. That's our 5-volt power. And we are going to power this with the 5-volt pin of the Arduino. And let's see if I got a little guy here. So we can see his pin right there, and I'm going to connect him like that and see if I can reach the 5-volt rail. Or it's not specifically a 5-volt rail, but it's the power rail of our breadboard. Maybe he needs to move in like that. There we go. So for those of you that are new to breadboarding, you can see the VCC pin right here. And tracing these line of holes, you can use any one of these holes right here. It's tapping into this red master line right there, which we eventually will connect to the Arduino. And then we know that the one on the outside right here, this 4th pin, is our ground. So I'm gonna go ahead, and this is kind of the only size I have, and you can see I picked a hole a little bit closer just to kind of burn some of this length that I got going on. And he's gonna go into the little ground there. All right, so anyone know what the maximum and minimum distance of the ultrasonic sound can handle, or the ultrasonic sensor? That is a good question. So it reads anywhere from 2 centimeters. You get any closer than 2 centimeters, it's blind spot, like some animals. They can't see real close in front of them. And it can read all the way up to about 13 feet. Past that, it can't see you. You're like invisible. All right, so that is a great question by Novux, or _Novux. So here we go back again where we were. All right, and so we have this thing almost hooked up. We got 2 more things to go, and I'm going to see here, the next one is, next to VCC is trigger pin. So we'll use green for that, and I'm gonna go in here, and let's put the trigger pin in 9. Just like that. And we'll use blue for the echo pin, which is right next to the trigger pin. So let's see if I can get these two like making friends, right? It's like in school where they put you sitting next to someone you don't know, and you gotta try and make friends with them. Could be fun, could be awkward. All right, so our little guy here, the ground popped off. See, we already got sassiness going on with this circuit. Don't want to cooperate. But this guy's fully hooked up. The only thing left is to hook up power and ground to the Arduino, but we'll get to that. Next, we got our servo. And for the servo, I am going to power him externally. You can certainly power one of these little guys from the Arduino, given that you're not going to add any loads to it. But if you're going to attach something to it, then it's best to power it externally. So Masonus Messi is asking, should I buy an ultrasonic sensor? I would say go for it, because you can build so many cool projects. All right. And yes, for James's project, it looks like he needs to get a little closer than 2 centimeters. So yeah, different solution for that. All right, so here, if you're not familiar with servos, the brown is your ground, the red is your VCC, and this particular servo can take up to 6 volts. So y'all know me by now, guess what volts we're going? Maximum voltage. And we also have our orange signal pin. So that one we know absolutely has to connect to the Arduino, because the Arduino is going to tell it how to work. So for this, I'm going to pop him into 7. And Carlos is saying, greetings from Colorado. I say greetings back. And all right, so we are powering this guy externally. So this is already being used for the 5-volt Arduino. So I'm going to jump onto this other side, and it's not really going to affect the ultrasonic sensor because he's kind of like hovering above it. So I'm going to go maybe right here, and purple is going to be my positive, and black, obviously my negative right there, although I frequently switch them around and then wonder why things are smoking, hence the burnt spots on my breadboard. All right, so I'm not going to tape anything down now. We'll see kind of how everything looks, but I'm pretty sure I'm going to want the Arduino over here. It's super important you don't have anything blocking its path, wires or anything like that, or else it's going to look strange. So I'm going to drag him over here in order to start preparing our test here. And the final thing, this guy needs power. So we have him plugged in, but no power plugged in. So I love picking up these female power adapters, making it super easy to plug into the wall. And you can see here, I have cleverly popped in some jumper wires, and this is kind of like my demo prototyping jack here. And I'm just going to plug him in and match up the red and black with the blue. And I'm going to cleverly kind of just maybe kind of weave him in here. It's all about weaving, people. All right, so he is all hooked up. Now, one super important thing is all of your components have to share a common ground. So you see we have stuff plugged into the ground here and stuff plugged into this ground, but they're not talking to each other. So we all know what we have to do. Everybody's got to kumbaya. Everyone's got to get along and talk to each other. So I'm going to connect those two, make a little bridge so all the grounds are connected. So finally, so we don't forget, this still needs power. So I'm going to jump a wire from our red rail here onto the 5-volt of the Arduino. And you can see right there, right next to the ground is the 5-volt, making sure I stick it into the correct pin. Got a little loosey-goosiness here, but I think we'll be good. And then ground from here, I'm going to put into right next to this guy. So everybody's got a friend here. It's like Bob Ross. Jumper wires could always use more jumper wires, just like clouds and birds. Everybody needs a little friend. All right, and for this guy, why don't we cleverly kind of put him here and tape him down? There we go. All right, guys, Nora is here as well. So many of you guys. And Carlos is saying he just started electrical school at his local community college. We're going to start Arduinos after Christmas break. Yes, that's so great. I am glad you're here too. So it's kind of tough to tell from this angle, but all the wires are running above the ultrasonic sensor, leaving a clear path. And so why don't, instead of, I went taping it down real quick, I'm going to move him here and see, making sure you guys have all this within your view. And then we're going to sneak some wires here. So of course, this is a 6-volt power source right here. And this is what's going to power our Arduino. And I'm going to set up a little ruler here, and we can try and position this guy. We have to remember that we need to leave a gap of about 2 centimeters. So if I get perhaps right up on here, that's our 2 centimeters, and maybe where my finger is, maybe that's kind of will give us accurate readings. Get within this area, that is the blind spot of the unit. So I think we'll be able to see everything there. Let's go ahead and code this thing. And I will flip you guys a little bit there. All right, so we got everything hooked up. If you guys have questions about the wiring or about how all this works, don't hesitate to post in the comments. Post in the comments of where you're watching below. And we also have a community, a private community, where if you are working on a project and you would like personalized help walking you through and helping you with your code, definitely check it out. A link for my community is below. So you know what time it is. To the code. All right, I'm gonna flip you guys over and look at that beautiful code. Here I come. Let me grab my mic here, not smack my head over it, but I have to do something super important, which is bring your comments over because they're like behind me. So I haven't developed my exorcist twist head yet, you know, like they have in the movies. I'll work on it for you guys. So let's get an idea of what's going on here. And this is the code I put together. Now, we wrote this in real time with our community members. So it's a video live chat where we can see each other and show each other our circuits and our code and where we're getting stuck. But this is what we came up with to move the servo according to distance. So of course we're working with servos. The very first thing we're going to do is include that servo library to make it way more easier to use the servo. Way more easier. Yes, that's we'll go with that. I always like to give specialized name to my pins, like unique names, I should say. You can certainly use and hard code the actual numbers, but if you guys are like me, you start a project and it just keeps getting bigger and bigger and bigger, and you have to move pins around, and now you have to go through all your code finding where these pin numbers are and change them. So if you set them up as variables, you have one place where you change all your pin numbers and it updates for the rest of the sketch. So here I'm using a constant integer, and that means it's a number that's not going to change. And for our servo pin, if you remember, we hooked it up to pin number 7, and you can call your pin whatever you want. And then we have our trigger pin, and that was hooked up to number 9, and then our echo pin, which is hooked up to pin number 10. And kick up the computer mic. All right, so some of you are like, you know what? This is a little too soft, so here we go. I amped up the gain a little bit, and I will also enunciate further. And going on, we have defined all of our pin connections. It was only 3. Obviously, we have some power and ground ones as well, but they don't really matter for this sketch. Next, we're going to have to make some variables, and variables are like storage containers to store some numbers for us. One is duration, the time. What is the time that it takes for the signal or the pulse to go back and forth? We need to grab that and store it for us. And we're using a float. Many of you guys see int all the time because this could end up being a decimal point. And int stands for integer, which is a whole number. So we got to use the right container for what we're going to store inside. Then I would like to get 2 different types of distances, the distance in centimeters and distance in inches, because depending on what you're doing, you might need both. You can also convert to distance in feet, in meters, of course, keeping in mind that this thing can only read up to 13 feet. So because my demo area is tiny, I'm thinking centimeters and inches is about as much as I can do. So UCC or VCC? VCC. And yes, VCC. My bad. Sometimes I get to talking to you guys and like other words come out. All right, next we have our servo. And so our servo needs its unique name. We have to create a servo object because you might have a lot of them. So if you're trying to control servo, it needs to know which one do you want to control. So I called this one my servo because it's mine. It can't get away as much as it wants to jump off the table. And so you start it with servo and then the name of your servo. So all that pre-setup stuff is complete, and we get into the setup. And the first thing I want to do is initialize my serial monitor so we can actually see the centimeters and inches that we're getting for troubleshooting purposes in case things look a little wonky. And then I set up my pin modes. So for the trigger pin, I want it to act as an output because we are going to be outputting 5 volts to that trigger pin to say, hey, send the pulse. And then the echo pin is going to act as an input because it's going to be receiving when that echo pin goes low. The Arduino needs to know that so that way it'll stop the timer. And then finally, we have our servo. We need to attach it to a pin. And here you can either put the number 7 or because I already defined it as servo pin, I put servo pin. So we've attached a pin to the object called my servo. All right. And James is saying sometimes we get distracted and hear differently too. Ain't that the truth? I do that all the time. And can classes be used in the Arduino IDE? Yes, it can. And we can certainly do some examples with those. And guys, if there's something specific you want me to demo or do or troubleshoot with you guys, let me know. I'm always listening. Most of these live streams come from your ideas. Because if you let me do my thing, I'm just going to do like monsters, props, applications, and all that kind of stuff. All kind of sci-fi stuff. All right. And I know you guys are working on other projects other than that. So we've got the setup complete. We're about to start measuring. So what is the first thing we want to do? Well, I know I said we're going to send a signal to the trigger pin, but there's like a little step before in that we want to make sure that we start with a clean signal because there is ultrasonic signals all around. And that's why that pulse is a very specific 8-pattern pulse because that's what the unit can detect is, oh wait, this is the signal that Rachel actually sent versus all the other stuff flying around. So we want the trigger pin to start clean. And so we're going to digital write that trigger pin low. And luckily, we don't have to do it for very long. So delay microseconds, we do it for only 2 microseconds. Super fast, faster than we all can blink. Then after that's done, now we can send the trigger signal. So now I'm going to take that same pin, the trigger pin, and now flip it to high. And the magic number that the ultrasonic sensor is expecting is 10 microseconds. So we're going to hold it high for 10 microseconds. And that's what initiates like, oh, Rachel for real wants us to send the signal. You know, she's not joking this time. So then after the 10 microseconds, we then write it low. So it's got a clean 10 microseconds. So now the pulse is going. It's traveling to wherever it's going to hit something. And, so Dipolar is saying his ultrasonic sensor has VCC, range, out, and ground pins. Do I have to change the code? No, not at all. So out is probably your trig pin and range might be your echo pin, but I'm sure you can match it up and you can just change this. You can keep it trig and echo, but for your case, you might want something more descriptive of what you have. So you can call it like out pin and range pin. And the code will be the same. Because the concept is the same. You want to start with a clean signal, send out your signal, and then start the measuring process. So here, what happens is this function right here, the pulse in function, is super helpful. It cuts down on a lot of the math that we're going to have to do. So as soon as this digital signal goes out or the ultrasonic burst goes out, remember that echo pin goes high and the timer starts. So this is the function that is going to work with that timer. So it's going to return a pulse duration in microseconds, which is great. And remember, we'll have to divide it by 2. So here, if it's set to high, because that's what happens when the pulse goes out, the pulse pin waits for the pin to go from low to high, and then that's when it starts timing. And then it stops timing when the pin goes back to low. So I have a couple notes in here for us. And so that's how we're going to get our duration. How long did it take for the pulse to go and to come back? So here, we're going to use the pulse in. It's going to measure that echo pin so long as it is high. All right, so now we have the duration. We don't know what it is yet. We have to do a little bit of math. So now we're going to take this time and we're going to convert from meters per second to inches per microsecond, because here we are using the speed of sound. by standards, speed of sound is 343 meters per second. Well, remember, we're doing everything in microseconds, so we have to convert this to microseconds, plus I want to get centimeters and inches. Meters is kind of way too big for my table. So that equals 0.034 centimeters per microsecond. All right, we're getting close now. So now that we have this in centimeters per microsecond, we can now grab that distance in centimeters. So what we're going to do is take the duration, the time in microseconds that it took to go and come back, multiply it by the speed of sound in the centimeters per microsecond, because we just converted. And remember, this is going and coming back. So we're going to divide it by 2, so we just get the going, and that is the distance to the object. So now we have the distance in centimeters. All right, and then we can take that info and do stuff with it. And now I'm going to convert to inches, because that might be a little bit easier for some of your guys' projects. And to convert to inches, well, 1 inch equals 2.54 centimeters. And I read numbers like a robot. All right, so the distance in inches, all we're doing is taking the distance in centimeters, which it literally just calculated, and divide it by 2.54, and that gives us the distance in inches. Now we can choose which version of the distance we want to use. So now, in order to make sure we have everything set up right, let's print this information to the serial monitor. So I go serial.print the word distance, followed by a space. Next, right next to that, we're going to print the distance in centimeters, which it calculated up here. It's just going to drop whatever it is up here down to here. Then we are going to print centimeters. So we know that that's the centimeters, followed by a separator bar, because right next to it, I want the distance in inches. So in essence, we have centimeters and inches, and they're going to scroll, or I guess they scroll up together, so you can compare that the math is working correctly and also the sensor is working correctly. It got dropped. We'll see what happens. And then we also want it in inches. So then it's going to print the distance in inches, which it literally calculated here. It's just going to drop it in there with the word inches. So that way I know which one is which, especially if you revisit this months later and you may not remember. All right, so we have the distance. Let's make the servo do stuff with this distance. All right, so if the distance in inches, so I decided to go with inches this time, is less than or equal to 6 inches, what do we want to do? We want to rotate the servo to 90 degrees. So I'm going to take my servo, because there could be several, but my servo in particular, and we're going to write it to 90 degrees. So in essence, we're creating kind of a cool thing where the servo, perhaps it's a head, a prop head, and it could just be looking to the side. And as soon as somebody gets within a certain distance, it looks at them. So you can use this for hunts, you can use this for attractions and exhibits, or fun robotic interactive elements. Or else, because what if the person has not come within 6 inches? If the object is further than 6 inches, we need the servo to stay at 0 degrees. So he's gonna have his head to the side like, I don't need to look at you. All right, so further than 6 inches, it's going to be at 0. And then as soon as it hits the 6 inches, this thing's going to look at you. All right, and Dave loves my Christmas shirt, of course, Nakatomi Tower. Christmas is coming up, and it is not complete without watching Hans Gruber fall from the tower. That's just my take. Die Hard is a Christmas movie. Debate in the comments, but I say it is. And you ain't going to change my mind. All right, guys, so let's upload this. And before we upload this, let me actually connect the Arduino. I think that would be super helpful right here. So I am just going to plug him in, and I'm coming back at you. And let's, oh, it's angry about something. So some kind of distance 6 inches. All right, so if the distance in inches is equal to or less than 6, then we want to write the servo. And let me make sure that I have my port selected correctly. It is, let's see. It could be that I'm missing brackets too. That's the else bracket, and that's the if bracket. And that's our loop bracket, which matches up down here. So it is getting super angry with this if distance is equal to or less than 6. So Alan was saying, hi, I'm new to this. Can I create my own? Can I create my own libraries or subprograms that can be called anywhere, anytime? Yes, a video on that. That's a great idea. I tried using serial printf distance, but it didn't compile for Arduino, but it did compile for ESP32 on the same IDE. Why was that an issue? Sometimes certain board packages, I did something similar, so I will dig up that code and see how I resolved it. And so, oh, somebody caught it. Somebody caught it. There we go. So this has to be reversed. You guys are like on it. All right. Here we go. And it compiled. All right. So is the space between the 6 needed? No. Like most coders will do this. The objective of coding is to get your code as compact as possible. You'll notice that I space out my code very much so. And the biggest reason I do that is simply for you guys, so you can clearly see what's going on. I think it's like visually helpful. I can certainly scrunch it up, but yes, you know, people try to make it as compact as possible. If you can write the same code in, say, 100 lines rather than 1,000 lines, of course, the 100 lines is the best way to go, and keep all of your arguments nice and compact. But I do this for visual purposes, making it a little bit easier for you guys to read. I know some of you guys are watching on your phones as well. So spaces are not needed. And all I'm going to do is pop the serial monitor here and let me prepare the next screen for you guys. And you can see the numbers are flying, but they're really tiny. So let's see if I can fix that for you. Here it is a little bit bigger. I'm going to see if I can kind of make them bigger. There we go. For you guys. And let's pop the camera down for you guys to see what's going on. And you can see we got 70s centimeters and then 30-ish, you know, inches. So that's all looking pretty good. And let's see if we can change the camera view right there so we can see what's going on. You guys can see the servo and all of that stuff. So let's get this more aligned here, make sure nothing is in the way. And I have this fancy box here, and I'm gonna put this at about the 25-inch mark. And we can see we're close, So perhaps maybe moving this up and calibrating it just a little bit without my hand all up being here, because you can see that it messes it up a little bit. And that's about right. So this 2 centimeter situation here is always a little bit tricky. And I'm going to bring you guys over. Somebody likes my spooky workshop. Why, thank you. So here we go. And oh, plugging in the servo would help, wouldn't it, people? Yeah, so I'm gonna go ahead and do that off camera. And we can see, assuming that the servo is 0 degrees. And you see, I put my hand, here's 6 inches, right here. So already that tells us probably good that it is working. And my serial monitor paused. What happened? Let me see if I can reset the Arduino. And for whatever reason, the Arduino disconnected from my computer. So let me reconnect it. I'll be right back. I'm crawling under the computer. Best you guys not see this. All right, so probably what happened is the USB cable was not properly plugged into the computer. So it happens. So I think we're pretty good here. And if you watch the servo, here I come towards the 6 inches, an unsuspecting victim. Oh, and it turns 90 degrees. Now look what happens to the numbers. Watch those numbers as I get to the blind spot. Look, they freak out. 2,000? I'm not at 2,000 centimeters. Are you kidding me? So yeah, it just freaks out, and so does the servo. So you want to make sure you're working within the range. And so here I come at 6, and bam, that creepy skeleton looks at me. So that is pretty cool. But what if, let's try this one, guys. I think this will be cool. What if we make the servo such that it starts at 0? And as the person walks closer to the ultrasonic sensor right here, the servo turns according to distance, meaning it'll start at 0 and get all the way up to 180 here. So it's almost like, and I think this would be super cool, it's almost like one of those paintings that has the moving eyes. And so the eyes are like this. And as the person walks towards the painting, the eyes slowly turn to look at you, like one of those creepy eyes following you type of paintings. We all know that. So I say we go back and just modify the code a little bit and see if we can achieve that. So yeah. And so James might have changed his mind. He said 2 centimeters might work for him. So that's awesome. So back to the code, guys. All right. So yes, be sure to plug your USB tightly into your computer, unlike me. All right. So all we have to do here is, why don't we change this up just a little bit? So that way we are going to map the distance to a servo angle. So bye-bye code. Famous last words, and it's like, oh, I needed that line, you know? So all the code stays the same, because all the way up until here, all we've done is grab the distance in centimeters and the distance in inches. So all we have to do here, and I'm going to put a couple notes for us, is simply map the distance that we get. So let's do it in inches first. Since we've been in inches, we'll do it in inches, to a servo position. So in degrees. So you see that we're mapping 2 different things, distance to degrees. So we have to make them talk to each other. So what I'm going to do is create a variable and call it servo position. And we're going to get this servo position by mapping from where? We want to map the distance in inches. And let's start it at, remembering that 2 centimeter blind spot. So 1 inch, right? So from 1 inch to 12 inches, isn't that ruler a foot? We'll call it 12 inches. And so 1 is going to correspond to 0 degrees. And 12 inches is going to correspond to 180 degrees. So we'll do it that way. Sounds good to me. And let's put a semicolon. So now we have told the servo, like, this is how we're going to map this, but we haven't told the servo to actually rotate to that position. So let's do that next. And so we're going to rotate the servo according to distance. All right, so let's go my servo, and we're going to write it. And we're going to write it by the servo position that it just calculated up here. It's going to pop it here in real time. So hopefully this works. The Arduino is still plugged in. I'm going to, oh, it's that distance. Oh, I put distance, capital I, capital N. Capitalization totally matters. So let's do it again. Type it way too fast. All right, it liked it that time. So I'm liking you guys. You're throwing shade at this code, putting the fear in it. So it's compiling a lot better now. All right, so I'm going to put us in this, back in this view right here. And I'm going to tilt this camera down, and you get a little bit of a freeze. And let me get it to, there we go. It tried to follow me. All right, so let me pop open the serial monitor. And thank you guys for bearing with me with new equipment. I figured I will try it out. So you can see it's freaking out. Like, why is it freaking out? Well, first of all, me doing this with my fingers is not a good idea. So here's our little box, and your victim is out of range, and it starts coming closer. Look at that. Now that flip is when you get out of range. Here, it starts to freak out. So here I'm out of range, and then it comes, look, and holding the box still. Now you can see that the turns are a little bit choppy. And the reason for that is because we are converting inches to 180 degrees. So if you are mapping a really big number to a really tiny number, you get more choppiness. So perhaps something like this, would it be maybe better to convert centimeters? Now you also want to hold your object pretty perpendicular to the unit. That is one downfall, I think, of the ultrasonic sensor, in that if you have a very furry object or something with an irregular shape, it doesn't bounce back right. So if I hold the box crooked and I go crooked like this, see how it's like, I don't know what's happening. So you have to make sure, and usually if you aim this at chest height of somebody's chest is typically pretty flat. So that's a good place to place a ultrasonic sensor. So I say, why don't we change, instead of distance per inches, let's do per centimeter and see if we can get this, this thing working. And the Unish also says his friend is not a box. So here we go. Let's, I say, we go back. And yes, sometimes this is an AI camera, so it'll try to follow me sometimes, even though I have it set to not. But like everything up in here, it's like, we don't listen to you. Please. All right. So hopefully your guys' components actually listen to you. I got like a whole bunch of like misfit components that constantly, like, their whole life's thing is to give me sass and make me nuts. So let me pull up your comments here, and let's, instead of distance per inches or distance in inches, let's do centimeters. And we got that 2 centimeter blind spot. So I'm going to start it to, and I'm going to go to 30 centimeters because I think that's the last thing on my ruler. And we're going to keep this the same. 2 will equal 0 and 30 will equal 8. So instead of going from 1 to 12, now we're going from 2 to 30. So it's not mapping such a tiny range to a big range. It's less tiny to a big range. So let's see if that works. Oh, it went through the first time. We're getting good, people. I'm going to move your comments. And I'm also going to do this. There we go. And I'm going to aim the camera down for us to see what's going on. And aim the camera down. All right, you gotta press this stuff hard. Here we go. Hopefully we're gonna get some smoother movements now that we're using smaller chunks. All right, it's more smooth now, so long as I don't get too close. So you can kind of do your creepy eyeballs. All right, guys. Pretty cool here. And I'm gonna get that thing off my head. It's like chopping my head off. So guys, I hope you guys had a blast. Hope you learned something and maybe get, a couple ideas going for the weekend. I'd love to see what projects that you're working on. If you have any questions about the wiring or the code, I actually have this exact same tutorial on my website, and link for it is below. So if you would like to just grab the code and play a little bit, kind of move things around, feel free to do so and post your questions in the comments, or better yet, check out my community. That way you can post up about your projects. We do one of these for community members only, but it's not a chat like this. It's actually live video. So you can show me your circuits, we can screen share and see where you're getting stuck. And I love my members. I get a lot of great ideas from you guys. And as always, continue pitching your ideas like, hey, I'd like to see this. I'd like to see that. So James is saying, thanks, you make learning this stuff so much fun. Yeah, you gotta have fun because you're gonna have to troubleshoot. No one's perfect. You can see with these lives, errors come up. We have components jumping off the table to try and save their lives. So stuff always happens. So guys, I will be back again on Fridays. I say, like, you know, fun little Friday afternoon with you guys always like kicks off my weekends. So I'm always looking forward to seeing you guys. So yes, again, if you have questions, post up, and I had a blast, and I will see you guys next time. Have a great weekend.